All right, this is group 7, lesson 4 meeting. All right, go ahead.
Okay, so my question on the number 5, it says an 8-sided die has 8 possible outcomes for each roll, 1 through 8. Calculate the probability of rolling a number greater than 5. So I didn't include 5.
Right.
Because it didn't say 5 or greater. So
right.
I have, so I came with, if you do it in fractions, 3/8. If you do it a decimal, 0.375 for greater than 5.
Yeah, I had the same.
And then calculate the probability of not getting a number greater than 5. You're going to take, I took that same window, 6, 7, 8, and I got 5/8 or 0.625.
Yeah. I got the same thing. And you can always, you did too, Chris? Yeah, you can always check yourself too with probability rule number 2, because they all have to sum up to 1.
Right.
So, yeah. Is there any questions that we had, like on part 1? Any of those?
I didn't really.
Yeah. It wasn't too complicated. It was just describe the rules. What was that, Chris?
Oh, well, if you actually click on the preparation answer key, they actually break it down how you get the answer. Huh. What?
This is for 5 and 6?
What's that? Yeah, 5 and 6. It actually breaks it down.
Gotcha.
That's pretty awesome. They've gotten better with their material.
Let's see. Let me go over there. I had it up at one point, but okay. All right. So it seemed pretty easy, simple, at least now.
Oh, did you see in this note under group meeting? Sorry to interrupt. It says the TA will be joining 2 different groups each week to help and assist you with any questions that may arise during your group meeting. Please watch for an email from the TA and be ready to add him or her to the group.
Yeah, I did read that. I checked my email earlier. I didn't see it. Maybe I should check it again. They could be waiting.
Oh, we have a group collaboration.
Yeah, that's just where we turn in the the recorded.
I thought so, but all of a sudden it seemed different. So how'd you guys do on your homework quizzes?
There's more. There's got to be more.
You guys will laugh at me. So I went to Houston for a wrestling tournament, got back at 10, had to do a bunch of project management. Nice. I literally did both of those quizzes. I submitted the last one with 30 seconds.
Nice.
And so I didn't even get a chance to do a second try. I got passing grades. I don't care. No, I'm sorry. I literally hit submit right at 12 because as soon as I submitted, the answers popped up.
Oh, wow.
So I literally got in under the line.
Serious. Yeah.
Which,
that's funny.
Any grade's better than a 0. So, right. You guys ready for this quiz, or did you have questions, Chris?
Was that a no?
That was a no.
Okay. All right, let's start this quiz.
Okay.
Okay. All right, we answer 1 and 2 on our own.
Okay. So you're required to work together as okay. Give your so we need to remember this. Give all your probability answers in decimals. Do not give probability answers as percents.
Okay.
So use the following information to answer the next 3 questions. Human blood can be classified into one of our basic groups, O, AB, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. For O, it's 0.45, A is 0.40, B is 0.11, AB is 0.04. Okay, the blood types and the proportions given in the table above define a probability distribution, true or false?
I would say true. They all equal 1.
They all equal up to 1.
Yeah.
Okay. Okay, what is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places.
Type O. Well, is it 1 in 4? Or do you look at population? Okay, wait.
Well, isn't
proportion of the
wouldn't it
Go
be
ahead, sorry.
Isn't it 0.445? Like wait a minute. I think I'm reading this wrong. The probability that a random
human blood can be classified into one of 2 types. The proportion. Okay, so the proportion means it's relative frequency. So let's see.
Okay, it says a probability is a number between 0 and 1. If you list all the outcomes of a probability experiment, such as rolling a die, the probability that one of these outcomes will occur is 1. In other words, the sum of the probabilities of any probability
It's got to equal 1.
So the probability that an outcome will not occur is 1 minus. Okay, those are the rules. So wouldn't the probability be the number the proportion that we're given, the 0.45?
Yeah, let's see the proportion. Yeah, although it's kind of funny that they say round to 2 decimal places when it's already rounded to 2 decimal places. That has type O blood. Here's my question. Okay, so those are proportions, and what a proportion is the relative frequency that each one would come up. So they're saying your frequency is more likely with O, and then A, and then B, and then AB. That's the way I understand proportion.
Okay, you're right, because it's not saying percentage, it's saying proportion.
Yeah, and so I'm wondering if I don't know, the probability, there's 4 of them. If someone's randomly given, there's 4 types of blood, so they have a 1 in 4 chance of selecting somebody has type O blood.
Oh, so we're overthinking this. It's really the proportion between 4, but except that, so it is a frequency. So if it's 1/4, and then we divide to decimals.
Yeah, and I don't know if that's right. I am willing.
1 divided by 4 would be 0.25.
Yeah. Like I said, I don't know if that's right. I'm just trying to figure out.
What throws me off is the fact that the frequency is higher, so our probability should be higher. See, this is what I was talking before we started recording, is I think, didn't they always say this, the assumption is that we always have an equal chance?
Yeah. even though the proportion, yeah. I know, I'm confused like you.
We're stumbling through this together.
Right, I'm just thinking out loud. I have no idea. That's very confusing to me too, because I mean, I understand what they're saying proportion-wise.
Well, because if we're correct in our thinking, because the next question is, what is the probability that a randomly selected person would not have? So that would be 1 minus.
1 minus.
Yeah, so it'd be 0.75. It'd be 3/4. If we're correct in our thinking, which I'm not absolutely certain we are.
So we're either like fantastically on top of this, or we are fantastically failing. but we're in it together. We're in it together.
We have 2 attempts.
That's right. They didn't used to let you do that, so.
Oh, I'm very grateful.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a See, I think that part of it is they give way too much information, and that also confuses.
Yeah.
So, lie down next to a specimen derived from a bladder cancer patient. Tangle, when the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as bladder cancer. If the dogs guess at random, what is the probability they will correctly identify the dish containing the specimen from the bladder cancer patient? So once again, we've got 7 bowls, and if only one of them is positive, that would be
1 in 7.
1/7, right?
Yeah.
Right.
Yeah, I agree.
And then you'd put that into a decimal.
Which is 0.143. Wait.
No,
Yeah.
the rule is the 2 is lower than 5, so you wouldn't round up. You would just leave it.
Well, it wants us to round answers to 3.
Oh, 3 decimals. So
yeah.
the 8 would round that 2 to a 3.
Yeah, 0.143.
0.143. Okay. Question 7 is, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely the dog would do this well by random chance alone. What of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence.
Provides strong evidence.
Chris, did you say yes?
Yeah, provides strong evidence.
Because it's more than half?
On their own. The chances are too great. They correctly identified 22 out of 54. That's almost half.
Yeah.
So it's a high probability. I mean, it's a high.
Yes, the dogs can actually.
Sorry. The M&Ms, the green's like blotted out. All right. So M&Ms are small chocolate candies. Get out. I did not know that. The M&M's website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given the following table. Brown is 0.13, yellow is 0.14, red is 0.13, blue is 0.24, orange is 0.20, and green is questionable. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Round answer to 2 decimal places. So wouldn't we first have to find the missing green to be able to? Okay. We're in agreement. Which really, it shouldn't be too hard.
Now, question, it's asking us for a probability. So would that just be, do you find the proportion? I mean, it looks like these are all proportions that they're giving right here. But to find the probability, isn't it 1 in 6? You have the probability.
Oh, once again, I'm not reading proportion. You're right. So 1 divided by 6 would be, whoops, equals 1.1666666.
So 0.1667, right? But
It says-
I don't know that. Sorry, go ahead.
No, I didn't. Go ahead.
I'm not saying I know that that's the answer. I'm just trying to.
So 2 decimal points is 0.17.
Yes.
Hey, when this video's over, you have to go to bed. All right, sorry. Okay, what is the probability that a randomly selected candy is green?
Wouldn't it be the same?
I would think so. If again,
It's
see, because
equal.
I didn't read anywhere where we took into when we do the probability in this lesson that we took into consideration the proportions.
Right.
Is that correct? Like, I didn't
Right.
miss that, right?
No.
Okay.
No. And from what I understand, probability is you take the number. What is our probability? We have 1 in 6 chance that we can pull out one of these things.
Okay, so question 10 is the probability that it's not green, round to 2 decimals. So that would be 1/6.
It would be 6/7. If we have,
Are there 7 different colors? Yeah.
Oh, no, you're right. There's only 6. Sorry, my bad.
So it's 5 divided by 6 equals 0.3333. So it says 2 decimals, so 0.83.
Yeah.
Which one's that one, number 10?
Yes, because we added up all the colors but green. Okay, the ACT scores of students admitted to a medium-sized public university in the Western United States was taken from the capex.com. The following summary statistics were calculated. Mean, standard deviation, variance. Okay, half of the observations are less or equal to what number?
24.
Yeah.
That's the median.
Yeah, that's what I would agree.
Okay. Based on the information on the table above, the top 25% of the students scored above what number?
The top 25. So above 27. Is that what you said, Chris?
Yeah, because quarter.
Because isn't that the
75th.
quadrant 3?
Yes. And above that would be 27. So that's the number.
Yeah.
Okay. And then question 13, which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability. That's true. The probability is a number between 0 and 1. We know that's true. If the probability is higher than the probability is positive. I think that's that one.
Yeah, I agree.
Yes.
All right. So do we want to submit? And either we are rock stars or we're gonna cry.
Hang on, though. Wait a minute. What was 8 and 9?
Oh. Hold on.
Yeah, sorry. Let me go. Go back, Liz.
You have to hit don't submit. Oh, no, that won't let me. Oh, okay. You just hit the number 8 and 9. Okay, so 8 0.17. Oh, wait a minute. Did we do that right?
I think
No,
so.
that wouldn't.
We did, because it's 6 colors, not 7.
Yeah, so 1 divided by 6. That's 0.17.
Okay. Because it says 2 decimal points. All right. Yeah. So, and 9, we assumed it was the same because there should be equal chance of getting one of those 6 colors.
But shouldn't, that's my question was, on the green one, we don't know that one. So shouldn't we add those up and subtract it from 1?
We did.
Okay.
Oh,
what
no,
they're
because that's the
showing-
proportion. See, I started to add them all up, and then Stacy reminded me that those are that data is proportion, not actual percentage.
That's the question we had, Chris, and maybe you understand it better. The proportions up there are the proportion. It means the frequency that somebody drew out. That
Right.
the probability. The probability, from what I understand, is the chance we have of drawing it out. And there's 6 M&Ms, and so if you reach into a bag, you have a 1 in 6 chance of grabbing out a red colored candy.
Okay.
But I am glad to be wrong, honestly, because this is all so much fun. So we can submit and see what happens, and then if we're wrong, then we'll go another route.
All right. So you got 0.17 on both 8 and 9.
Yeah.
Okay.
Are we ready to submit?
I think so.
Oh, we are not right on those.
Ah! Okay, well, I'm going to submit mine just because we have to do it together. Okay. Let's see. Okay, let's go. So what is the probability that a random selected person has? Okay, so you're right. We're not.
So we should then add them all up and subtract that to get that.
You want to try that?
3.14. 0.3.
It's so frustrating to me. It's so confusing.
So the frequency is our probability.
That is the probability? I, the me. Okay.
Okay, so how do we do this again?
Okay, so you just go back.
Subtract it from 1.
What was that?
Wouldn't you just add them all up and subtract it from 1?
Yeah, but we got the blood ones wrong and the M&M, so that means that we were thinking it wrong.
Yeah. So in order to go take that quiz again, go.
Do the back arrow.
Yeah, go to the back arrow and then start quiz again. So do we want to go look at lesson prep again to go look at some things? Let me go read something real fast. Okay, let's see. Okay, notation. I mean, is that where you start using?
And I thought I had it in my head, but now I'm all confused.
Right, I am too.
Well, because we felt like the verbiage was wrong, but if it's still like those numbers have to equal 1, then our original thinking was correct, and that we're just working with different names.
Yeah. I'm so lost.
Okay.
Yeah, that was what confusing to me is I would think, okay, I think I got it. And then let's see. Okay, I'm coming to some. Okay, remember how they had those dice? A man rolled the dice 6,000 times, recorded the results, and then it was asking us how to find the simple mean, but it's not. Let's see. I'm just trying to go down and see if I can figure out probability.
Go to bed with Daddy.
Okay, they were talking of proportion, right?
Okay, so we have what's called the rule of sample proportions. Did we?
Yeah.
How do we do that?
Okay, so what they did was they took the value. So say green was or whatever color was 0.45.
Right.
And so this is the dice. So they rolled it 6,000 times. That was the number. And they took the proportion, which was 1 was rolled 1,047 times. And then 2 was rolled 968. So there's that proportion. And then they went and, hey, but see, I'm not sure what that has to do. So maybe they're asking us to find the true probability, which, see, that's what I'm,
Okay, so
see, I'm confused. I really am.
probability has to equal 1, right?
Yeah.
We already I'm not gonna ask my husband because he overthinks it. He way overthinks it.
Well, see, here's what's crazy. So I'm going down and reading it, and if they're asking us to find probability, like I'm reading down here about that whole dice rolling where they find
Right.
the probability still says it's 0.1667 because it's 1 in 6 chance. That's what probability is.
Probability is, yeah, the probable of an X outcome.
Right. So I'm not sure why we got those wrong, because to me it still makes sense that the probability is there were 6 M&Ms and the probability of grabbing out 1 is still 1/6.
See, this is the problem with these quizzes is our answer wrong or are our decimals off?
Right.
Because we'll have it marked wrong either way.
Right. Frustrating.
Because
well, we can't get worse by trying it the other way.
That's true. I just feel like
that
whole section with the rolling the dice, the finding the mean, wasn't exactly what they were asking. So like I feel like doesn't really address what they were asking.
Right, they weren't asking that.
Unless we use that data in the same way.
And figure out that whole formula, that whole page where you have to go through and find the sum and the standard deviation.
Yeah, which doesn't.
What would that probability?
Yeah, that's my question. It doesn't have anything to do with probability in the sense of it's finding the true mean and the true. But like when you go down and look at the charts, and it says first, here's your value 1 through 6, and then what is your probability of rolling those? If you look at it, column 2, it still says every single one of them is 1/6 or 0.1667. Yeah. And then to find the true mean, you use that probability to times it by the value, but we're not trying to find the mean. We're trying to find a probability. Arg. I am so confused.
Well, we really only have two thought process. Either we use the data as given, because if you remember in the video, he had numbers, assigned numbers. Did you guys watch the videos?
Mm-hmm.
Like it wasn't the M&M one for specifically the M&M one. It wasn't equal. All the numbers were. It wasn't like 1/6, you know. They were different numbers. So really we only have two thought processes. Either, and the first one was we thought it was just purely based on a division between the possible outcomes.
Yeah.
Or we use the data that.
Well, do you want me to pull up that video and do we want to watch it together and see what we can figure out? I can pull it up and throw it on the screen.
Sure.
Okay. Let me do that. Okay. Let me do that. There. Come on, computer, go. There we go. Yeah, I can see what you say, Carrie, when it starts getting really confusing.
I thought I had figured this one out.
Yeah, me too. Okay, sorry, I'm coming. I'm almost there to where we need it. Okay, which video was it? Just the one under the online textbook?
I think so. It starts with the temple.
Yeah. Okay, so I'm going to.
Because the one at
Okay.
the bottom talks about a four-sided dice.
Okay. Let's see. All right. Tell me if this is the one. Do you see it?
Yes.
Yes.
Okay. Okay. All right. Let's go. Let's watch it and see what we can figure out. Come on, really. Sorry, I'm getting there. All right.
This is Brother Corman from the Mass Department at BYU, Idaho.
Yeah. Let's see if we can. Do you guys want me to skip forward?
Yes, it's about halfway through. Yeah, it's about a third of the way through or something like that.
Yeah. Okay, I'm looking for it.
It was right after this one, I think.
Okay. Okay.
Okay, so I have a question then.
Okay.
Is the p-value the mu, is that probability? Because in my notes I have that the p-value equals the mu, or the probability.
Yeah, P. Yeah.
So if the p-value is mu, then we've got to solve for mu, for probability.
Yeah.
See, okay, see right here in the example, he's got different numbers.
Yeah. So let's see what he
So
says. Should we see what he says about it?
Yeah. I can't hear him.
I can't either.
You said what?
Hear him.
What did you guys say? Sorry, I didn't catch it.
We couldn't hear it.
We can't hear the
Okay.
video.
At all?
No.
He was saying that the probability of getting one color, he said red was 1%, green was 1%, blue was 1%, yellow was 2%, and orange is 3%.
Okay.
Which that's what you guys were thinking. You guys were right. Like if it's explained that way. So let's
That we use the data. So they see. So they're essentially they're trying to trick us. They instead of using. That's kind of the way I.
Yeah.
So then that means that the blood type one would be 0.45.
Yeah. That's at least it sees. Should we listen to him for just a couple more seconds and then we can go back?
Sure.
Let's do it. Okay. So I think you guys were right. I think you guys were right on your first thoughts. I mean, at least that's what it's heading towards. So let's, we can go back and do that.
Now, write down your answers on the ones we got right, because we're going to have to do them again. Or I printed it,
Oh.
so I'll be the script.
Submitted the
Okay.
one yet.
Well-
So let me write down the answers that you've got, and then let me submit the first time with the answers I just put in and see if they're right. That way you won't waste your second
Okay.
time.
So everyone ready to start?
I'm getting there. Let me get to the right spot. Okay. Come on.
Like you said, that we can only go up. We can't get worse.
Okay. All right. So we're back to question 3, right?
Right.
Okay. On
That one
question
is
3.
true.
All right. My question 3 is straight into the blood chart. Oh, yes. Sorry.
That's
Okay.
that's a problem.
So what's the probability that a randomly selected person? So we are going to use those numbers to add up, right?
Okay. Yeah.
No, the possibility of a random having type O is 1 in 4, because they have a chance of having any one of those 4 types.
But that's how we
But-
answered before.
That's what we answered before, and it was wrong. And if we take this to look the same as that M&M chart, what they would say, because
Be a
do all those numbers add up to 1? All those numbers add up to 1. I think we added them up.
right.
And so I
So
would
then
say
it would
this time
be-
answer. Go ahead.
So wouldn't it be 1 over, well, we have to convert 0.45 into a, oh, so, well, remember we were arguing, like, wouldn't it be right there, 0.45?
Yeah. Yeah, that's what if we follow his example with the M&M chart, that's what I would say.
0.45?
Yeah.
But on the flip side, we would add up the other ones for the
Yeah, or we
not-
can minus, we can minus 1.
for
Or,
the 1 minus 0.45.
yeah.
If we give you 0.5,
Yeah.
I have 0.55.
Yep.
yes. Okay, so don't submit your second one until I submit this first one with these answers.
Oh, you haven't even we're recording. You're not supposed to say
Oh, sorry.
that. Okay.
Oops.
So if the dogs guess at random, what's the so we got the dog ones right, correct? La, la, la,
Yeah.
la, la, la. Okay. So number 6, if the dogs guess at random, we had 0.143.
Because we divided 1 by 7 chances, right?
Right.
The 7
Yeah.
into 1.
And
We had a
then
1
question
chance.
7 was if there's 54 trials, there's 22. Yes, there is strong evidence. And now we're to the dreaded imminent. Okay. So red would be the 0.13, right?
Yeah.
And then,
30% of them are red
okay, and
in
then
the bag.
so the green, which we have to figure out, we figured if we using the other numbers, adding them up,
And then
I
minusing
got
from 1.
I got 0.16. But let me since we only have one try, let's double check my math. So
I got the
0.13 plus 0.14 plus 0.13 plus 0.24 plus 0.20 equals 0.84, and then 1 minus 0.84 equals 0.16.
Yep, I got the same.
Okay. And then number 10 is what is the probability of that randomly selected candy is not green, which isn't that the 0.84?
Yeah.
That's where you would take the 1 minus the 0.16.
Yeah.
Okay.
Okay. And then the rest we had the correct answers, which number 11 was half the observations are less or equal to what number? And Chris said median, which is 24.
Right.
And then based on
Yeah.
the top 25%, which is the quadrant 3, which is 27. And then we said the one that's not a rule is the probability is high. Okay. You got your answers, Chris?
Yeah.
Go ahead and submit.
Yeah, hang on a minute. I'm going to make sure. So I don't want to give you guys a.
I'm feeling confident this time.
You are, huh?
Yeah.
Well, I kind of feel like we only had 2 options, you know.
Right.
one
We go in one of the 2 directions.
Right. That's how
Yeah.
I felt.
All right, let's see what we got.
All right. Did you submit, Carrie?
No, have you?
Wait.
Uh-uh.
Submit it.
The right?
Yep.
Ah,
Yay.
Seen it.
teamwork.
Oh,
I'm going with you guys the first time next time. You guys are on.
Shucks.
shoot.
You're so sweet.
Now I was confused. I thought I.
All right. That totally stressed me out.
But okay, so this is that one semester I did. We only had 1 try, and so literally we would pick one person to submit, and then they would quickly go, "Oh, 4 is wrong." 4, you know.
Yeah.